Good afternoon or morning. Welcome to this video on how to find the sum of an arithmetic series. An arithmetic series, you remember, is one just like this one here, which goes up by the same amount every single time. We can see all we're doing to this one is adding on 3 every time. Absolutely fine, no problem there. And we're given the formula for these two things. This is in your formula booklet. It's a very helpful formula for helping us. This video is looking at how we can get to this formula here, the sum of a number of terms. And before we see how we do that, a little anecdote. Cast your mind back a few years to when Gauss was a boy. Gauss was a tiny child. Perhaps you had a baseball cap on which said I heart pi or something similar. He was a young gun, and he was at school, and he was so good at maths that his teacher needed something to keep him busy, to keep him occupied for a little while, because Gauss kept getting the answers so quickly that the teacher gave him a real challenge. He set Gauss a challenge of adding up all of the numbers from 1, 2, 3, 4, 5, 6, 7, 8, 9, all the way up to 100. And rumour has it that the young Gauss, primary school age, came back to his teacher after a few seconds with the number 5050. For a start, the teacher didn't know whether that was right or wrong, but it looked quite convincing. And so he said to Gauss, how on earth did you get this number? And Gauss said that he looked at the number 1, and he looked at the number 100, and he said, these two must add up to what number? They must add up to 101. And then he said, I've got the number 2 and the number just here, 99. What will they add up to? They'll add up to 101. Similarly, 3 and 98, 4 and 97, they'll all add up to 101. How many pairs of numbers have I got? I've got 50. I've got 50 lots of 101. What does that equal? Lo and behold, 5050. Absolutely fantastic. Incredible by anyone's standards, especially a tiny child. Very impressive indeed. I'm sure that's what the teacher said. Either that or the cane, things were different back then. What we need to do is see why this works. It's nice that it does, but is there any way that we can actually see why it works? Let's think for a second. If we've got a sequence with a few terms in it, second, third, all the way up to the nth term, what would we call the first term? How do we define that before? That was A. The first term is defined as A. The second term we defined as A plus the common difference. We add on the difference once. The third term, similarly, is A plus 2D. And so on and so on and so on. What about when we get to the nth term? That one will be A plus n minus 1D. Just as we had before. A plus n minus 1 lots of D. Okay, now let's have a little look at what we get if we add these together. We call this the sum, choose a green. The sum of the formula, a sum of all of these is A plus D plus A plus 2D plus all the way up plus A plus n minus 1 lots of D. Okay, now we do a trick, which is something you don't need to remember, but it is a sensible thing to look at. What if we write out the sum of all the numbers again, but in the opposite order? So we write the last term first, the nth term, that was A plus n minus 1 of D. And then the next term along, whoops, I'll put in a different colour sign, this we'll see the break, and we'll define this as A plus n minus 2 lots of D. So that's the very last term is here, and the second last term is just here. Okay, so once we've done that, we can have another look at these ones here all the way across, and we add on the very first term, we just get A. And then what we do is we see, what do we get if we get two lots of the sum of all the numbers? And we add this term to this term just here. That gives us 2a, so we've got 2a just here, plus n minus 1d. That's what the first term and the last term give me. And then these two terms just here, my second term and my second last term, what do they add up to give me? They give me a 2a plus n minus 1 lots of d. Oh, that's interesting. That's exactly the same as before. All the way up to the very two last terms, sorry, the last term just here and the first term just here. What do I get? Lo and behold, 2a plus n minus 1d. In fact, we can see that we get the same term here and here and here. How many lots of this have I got? I've got n lots of 2a plus n minus 1d. Wonderful. Nearly there. Nearly there. Two lots of the sum of all the numbers is n multiplied by 2a plus n subtract 1 lots of d. Then I can just finish it off by writing one lot of the sum of numbers then is n over 2a plus n minus 1d. Wonderful. We don't need to know this off by heart. We don't need to memorize it, but it is a very, 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 very handy thing to know where it comes from, because it will help you to apply it later on. Okay, just to check, what do we say? N over 2 multiplied by 2a plus n subtract 1d. Let's see if that's what we got up here. Yeah, there you go. Exactly the same as what we had before. Cool. Fantastic. Thank you very much for listening.